Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. Okay, we'll be going straight to the second form of transformation of a graph, which is the stretching of a graph, okay? We finished with translation, so please try as much as possible to review previous video. If you've not subscribed, liked, or shared, I don't know what you're waiting for, make sure you subscribe. Click on the notification button as well, so that when I post new videos, you'll be the first person to know. All right, let's get into it. When a graph is said to be stretched, it means that the graph is enlarged or reduced in one direction. So that means the graph is either enlarged or is reduced in one direction. So let me just write it down here. So a graph, okay, a graph is said to be stretched if the graph is enlarged or reduced in only one direction. It's enlarged or reduced in only one direction, okay? So let's get this sorted now. So there are two types of stretch we're going to talk about in this video. I'm going to talk about stretch. So we're going to talk about two types. The first one I'm going to talk about is stretch in the y direction, or you can call it a vertical stretch. Okay, stretch in the y direction or vertical stretch. Or also, you can also find the stretch in the x direction and or horizontal stretch, okay? So now for the vertical stretch, what it means is that the stretch in the y direction, it means that if, for instance, you have this graph, okay? This is the original, this is the x-axis, right? And we know this is the y-axis, okay? And the graph we had initially was this. Let me draw a better one. So we have this graph here. Okay, now a stretch in the y direction or the vertical stretch, what it implies is that the new graph will be stretched in this direction, okay, to the y direction. Can you see? It's going to be stretching towards the y direction because, and the new graph you're going to have will be something like this. So it's going to be something like this. So you see the initial graph has been stretched in the y direction to give you what? This new graph. Now the second one I'm going to talk about is the x direction or horizontal stretch. Okay, so you're gonna have the x direction or horizontal stretch. Now this is exactly the same thing, but in the opposite direction, okay? So now this is not, instead of stretching to the y-axis, as you can see, it was stretching to the y-axis, which is here, the vertical axis. But in this case, what you'll be seeing is the opposite. It's going to be stretching to the x-axis. So if this is the x and this is the y, okay? This was the original one, okay? So now in this case, it's going to be stretching to the what? To the x-axis. So the graph is going to be stretching to the x-axis. All right. And the new graph you're going to get is going to be look like something like this. Okay. So it was initially the red one. Now it's going to be stretched to give you the black one. All right. Good. So I'm gonna quickly spend like few seconds or few minutes to explain each and every one of this. So I'm gonna first start with the stretch in the y direction, okay? So I'm gonna start with the first one, stretch in y direction. of vertical stretch. So stretch in the y direction of vertical stretch, okay? So let's go. So that means if you have y is equal to f of x, a particular function, and you're stretching it, okay? You stretch in y direction, okay, by a factor of k. So that means what you're using to stretch is by a factor of k. What it means that the new function is going to be y is equal to k f of x. Are you seeing it? So that means when you stretch it in the y direction, you multiply the original function by the factor, okay? Or if, for instance, you have y is equal to f of x, you're stretching it as well by 1 over k, okay? So you're still stretching in y direction, okay? You're stretching in one direction. The same thing, you multiply the original function by what? 1 over k f of x. So remember, in this case, the k is equal to the what? The stretch what? Factor. So the k is the stretch what? Factor. All right, so what do? How do you do this? So from this, you can see you multiply the original function by the stretch factor, all right? You multiply the original function by the stretch factor. So I'm going to write it down because I'm aware some of you do write as well. So therefore, how you do this? So therefore, when stretching a function, so when stretching a function like y is equal to f of x, so when stretching a function, in y direction, so remember we're stretching in the y direction, okay? By factor of k, it could be k, or it could be 1 over k, it does not really matter, it could be anything, all right? You multiply. What you do is that you multiply, that is the key word, the entire or the whole function. So you multiply the whole function by the factor. So if the factor was k, you multiply the entire function by k. If the function was 1 over k, you multiply the entire function by 1 over k. Let me quickly pick an example. So if, for instance, we have y is equal to f of x, and we want to stretch this by a factor of 5, okay? So we're doing a stretch, okay? We're doing a stretch in the y direction. Okay, we're doing a stretch in the y direction. What do? You multiply the whole function by the what? The factor. So this is going to give us 5 f of x. So that means this particular function is stretched by a factor of 5 in the y direction. Okay? So, or if you have y is equal to f of x, now in this case, you're stretching by 1 over 5. So stretch in y direction, then y is going to be 1 over 5 f of x. So if you have to describe, for instance, the first one, if you are describing the first one, it is going to be the function f of x is stretched by a factor of 5 in the y direction. Okay? And if, for instance, you want to do the second one, you want to do this one, okay? The same thing. You do it. The function, okay? You say the function f of x is stretched by factor of 1/5 in the what? In the y direction. Okay, so you can see that if you're stretching in the y direction, you multiply the whole, okay, the whole function by the stretching factor. All right. So that is that. So we've talked about stretch in the y direction, right? So let's pick one. Let's go to the next one. Stretch in the what? In the x direction. So let's quickly talk about that. The stretch in the x direction. So the B part now, okay? The B part, so let's say we have the stretch in x direction. Or horizontal stretch. Okay? Horizontal stretch. Okay, let's see. Stretch in the x direction or horizontal stretch. Now, in this case, we talked about when it was stretching in the y direction by a factor of k, we said you multiply the whole function. But this for in the x direction is a little bit different, just a bit. Now, when you have y is equal to f of x, and you're stretching it by k now, but in this case now, you're stretching in the x direction. Okay? Now in this case, you're stretching in the x direction. Okay? So we're trying to explain this one. This is stretching in the x direction, while the first one we talked about was in the y direction. So we're talking about the x direction now. What you do, the y will be equal to, instead of you multiplying the entire function by k, what you do, you only divide the x by k. Are you seeing it? So now the difference between both of them, the first one, you multiplied everything by k, the whole function by k. Now, but in x direction, you only divide the x by k. Similarly, when you have it as an inverse, it does not matter. So you're stretching by 1/k, but you're stretching now in the x direction. Now you're stretching in the x direction. The y is going to be f, the same thing, x divided by 1/what? K. Now, usually, because of to make this easier to write, some textbook will not write it like this. So because it's 1/k, because it's divided, to remove the division, you flip. Does that make sense? So the k is going to go up. So it's going to give us y is equal to f kx. Are you seeing it? So you need to notice. So in both of them, we know that where k is equal to the stretch what? The stretch factor. Are you seeing it? This k is equal to the stretch what? Factor. So you divide your x by what? K. So you can write it like this, or you can write it like this. Any one is fine. All right? So, but usually in the textbook, they'll prefer to write it like this because they're trying to simplify this further. So because I'm aware that some of you are also writing, what I'm going to do is I'm going to write it as well so that you can take notes as well. So therefore, all right? Okay, so therefore, when stretching a function, in the x direction, okay, by a factor. So it could be a factor of k or 1/k. It depends. It does not really matter, but just by a factor, it could be k, it could be 1/k, it could be ab, it does not matter. You divide. The key thing here is that you divide. Now, in the previous one, what we're doing, we multiply, okay? Now, but this time you divide the x, okay? only the x in the function by the stretching factor. Okay, by the stretch factor. You divide, okay? You divide. The keyword here is divide, okay? So let's pick a quick example so that, like I did here. So if, for instance, we have y is equal to f of x, and you're stretching this by 5, but this time you're stretching in x direction, okay? So in the previous example I did, okay, in the previous example I did, we're stretching the y direction now, but now we're stretching in the x direction. But the factor of 5, so it's going to be y is going to be equal to f of the x you divided by what? 5. Beg your pardon? So the x you divided by what? 5. Now, if, for instance, you're stretching by 1/5, so now you stretch in x direction, okay, by 1/5. So the y is going to become f of x divided by what? 1/5. And like I said, the 1/5, you can simplify this further. You take the 5 up, so it's going to be y is equal to what? F of what? 5x. And that will be the answer for that. All right? So how do you write this? So the same way you do this, you write exactly the same thing, but you instead of putting the y direction, you put the x direction. So that means for the first one, we can say the function, if you are told to describe the function, f of x is stretched by a factor of 5 in the what? X direction. Okay? Now, if you want to describe the second one, okay? Want to describe the second one, you do something similar. Now, but in this case, the function, so although you are having 5 here, but it's still stretched by 1/5. Does that make sense? So the 5 here is because you simplified this. Is that right? So that means the function f of x is stretched by a factor of 1/5 in the x direction. Okay? It's stretched by a factor of 1/5, not a factor of 5. Although you have 5 here, the 5 is gotten from this point here because you simplify. Okay? So it's stretched by a factor of 1/5 in the what? In the x direction. Okay. So we've explained quickly the stretching in the x and the y direction now. So, and I use the general form, okay, f of x. But now let's go to the next part. What about if, for instance, I give you y is equal to x squared plus 7x plus 12, and I told you that this was stretched by a factor of 5, and it was stretched in the y direction. For instance, it was stretched in the y direction. Okay? What is the new function? Are you saying now? So in the previous one, what we did was I just gave you the general form and we solved it. But now I'm more specific. So we're delving in now in more. How do you go about it? All right? So what do? I'm going to start now. So I'm going to show you how to do it. So I'm going to write, I have 5 rules or 5 steps on how to do it. So the 5 rules for finding the new function. new function or equation after stretching a graph, okay? Is that in the X or Y direction? Okay? So the 5 rules for finding the new function after stretching in the Y direction. So the first thing to do is that you have to write the original equation in standard form. So number 1, you write the original equation. In standard form. Okay. So for example, if you have let's say y is equal to ax squared plus bx plus c. So for instance, this is a standard form for quadratic. Okay. So if for instance you have a quadratic equation, you have to write it in the standard form, in the form of ax squared plus bx plus c. Then number 2, when you've written in the standard form, the next thing then you have to do is to identify the stretch factor. Okay, stretch factor K. Then number 3, after that, so if you're stretching in the Y direction, so let's pick the first one. So if you're stretching in the Y direction, so if it's the Y direction, so that means we're talking about you stretching in the Y direction. That means the first one now. So if the question is to stretch in the Y direction, what you do, the first thing you do, you replace all the Y values. So you replace all Y values with Y over K. So anywhere you see Y, you replace it with Y over K, and all the X values remains the same. Okay, if you stretch it in the Y direction. Now, but if you're doing this, if it's in the X direction, basically what you do is the opposite. Is that okay? If it's in the X direction, what you do, you replace all X values. So you replace all X values with X over K. Okay, then, but instead of replacing all of them with X over K, now in this case here, the X is gonna what? Remain what? The Y is, I beg your pardon, the Y is gonna remain the same, because in the first one, the X values remain the same, but here, all the Y values will what? Remain the same. Okay, so if you're doing the Y direction, you replace all the Y with Y over K, and the X remain the same. If you're doing the X direction, you replace all the X with X over K, and the Y will remain what? The same. Then when you're done with that, number 4 is then you then expand and simplify. Okay, so you expand and simplify to get the new equation. Okay, and number 5, okay, you sketch new equation. So you can call it new equation, or you can say the new function, anyone. So you then sketch the new equation or the new function, all right, to see, all right, how the new graph will look like. but this is if needed. It's not compulsory, okay? If the question asks you to sketch, then you sketch. If the question does not ask you to sketch, you don't have to sketch. And I've talked about how to sketch quadratic equation, rational function, exponential functions, linear functions, several types of sketching, all right? So because of time, I'm not going to sketch, when we solve a question, I'm not going to sketch it. I'm going to just use the Desmos graph and just show you, all right? But if you want to sketch, please go to the playlist. I have different videos on how to sketch each of these graphs, okay? I have different videos on how to sketch each of these graphs. Okay, so let's pick an example here, all right? Let's pick an example here and solve. So we have this, okay? We were told that given the equation, okay, we have a particular equation, y is equal to x squared plus 5, all right? This particular equation is stretched. This particular equation is stretched, okay, by a factor of 2, okay? So we're stretching this by a factor of 2. Now, it's not asking what will be the new equation if it is stretched in A, the y direction, and B, the x direction. So we want to see how the difference with this graph, we have x squared plus 5 when it's stretched in the what? In the y direction by a factor of 2, and when it's stretched in the x direction by a factor of 2. So basically what I'm saying is that we're having y is equal to x squared plus 5. We're stretching it by a factor of 2. Now we want to stretch in the y direction. Okay, the y direction, we want to know what is going to be the new equation. Or when you have y is equal to x squared plus 5, now you're stretching by a factor of what? 2, but this time you're stretching in the x direction. Okay, we want to stretch this in the x direction. And the question now is then, what will be the new what? Equation. So let's start with the y direction, okay? So I'm going to start with the y direction. So let's go. So we have in the y direction. So what would that give you? So number 1, in the y direction, good. So let's go to the steps. So step 1 said that we have to write the original equation in standard form. Okay, so let's go. So step 1, the original equation we were given was x squared plus 5. So that means we can write it as y is equal to x squared plus 0x plus 5. But because 0 is nothing, I'm going to just leave it as y is equal to x squared plus 5. Good. Standard form. Number 2, they said we need to then identify the stretch factor. So let's find what the stretch factor from the question. It said it's stretched by a factor of 2. So that means we're having what? 2 here. So step 2, k is equal to what? 2. Then the next thing, step 3, it said if stretching in y direction. Okay, so what is the question we're looking at here? We're stretching in what? Y direction. Good. So, but it said if stretching in y direction, replace all the y values with y over k, and all the x values will remain the same. So let's go back. So we're stretching in the y direction. So we have y is equal to x squared plus 5. Everywhere you see y, you replace it with y over k, so y over 2. But the x is going to remain what? the same. Okay, now step 4. Okay, step 4. Step 4 said we then have to expand and simplify to get a new equation. So we have to expand and simplify to get a new equation. So we have y over 2 is equal to x squared plus 5. To remove this 2, I'm going to multiply both sides by what? 2. I'm going to multiply both sides by 2. So that means y is going to give us 2 into bracket x squared plus 5. So if you open the bracket, so y will be equal to 2x squared plus 10. Okay, y is going to be 2x squared plus 10. So let us see this graph. Okay, so we have, so therefore, we had a y is equal to x squared plus 5. It was stretched by 2 in the y direction. So stretch in y direction by 2, and the new graph we had now was y is equal to 2x squared plus 10. I remember I told you in the beginning that when it's stretched in the y direction, that means the original graph is going to the y direction. Are you seeing it? All right, let's go and check. Let's see. All right, let's sketch this graph and see if it's going to give us this. So we have x squared plus 5 and 2x squared plus 10. So let's do this. So we have x squared plus 5, x squared plus 5. Okay, so this is how the x squared plus 5 graph looks like. All right, now let's go. The second one, the answer we got was y is equal to 2x squared, 2x squared plus 10. Are you seeing now? Can you see the difference? So the green one was the original graph. Are you seeing the green one was the original one, yes, while the purple one was the transformed one. And you can see that it was stretched in the what? In the y direction. So initially it was there, but all the graph, it has been stretched what? To the y direction to give you this, which was similar to what we got the first time. Okay, good. Now let's go to the part 2 now. So we stretch this in the y direction. Now, but the question said, okay, what will be the new one when we stretch in the what? In the x direction. So let's do that. When we stretch in the x direction. So that will be number 2. We have in the x what? In the x direction. So when you're stretching in the x direction, what would that be? Okay, so let me get this up here out of the way so I can write in the x direction. So what do? Step 1, we follow the same step. So we have step 1. You write it in the standard form, right? So that's what they said in step 1, right? They said you have to write the original equation in standard form. So we're going to write it in standard form here. So y is equal to, we found that to be x squared plus 0x plus 5. But because it's 0, it's going to be y is equal to x squared plus 5. Okay? Now step 2. Step 2, same thing. Said identify the stretch factor. So we're going to identify the stretch factor here. So the k is equal to what? So in the question, we're told the stretch factor was what? 2. So step 2 is going to give you what? K is equal to 2. Step 3. Now remember now that we're stretching in the x direction. So in step 3, we're going to look at only when it's in the x direction. So for the x direction, we're told that you have to replace all the x values with x over k, but the y will remain the same, okay? So let's go back. So we have y is equal to x squared plus 5. The y is going to remain the same, so we're going to have y. But anywhere you see x, so that means technically we're going to replace this x. So anywhere you see this x, you're going to replace it with what? X over k. So let's go. So anywhere we see that x, we're going to replace it with what? X over what? K is 2, and all is this is squared. Are you seeing it? So this x, the squared is going to be same thing, but anywhere you see x, you're going to put x over k plus 5. So step 4 now, okay? So step 4. So step 4, what step 4 says? Expand and simplify to get a new equation. All right, so let's play around now. Let's expand. So we have y is equal to x over 2 squared plus 5. If you open the bracket, is y is equal to x squared divided by 2 squared, right? Laws of indices. Please, if you've forgotten the laws of indices, please go back and have a look. I have a video on this, okay? And we'll talk about the several laws of indices. So we now have y is going to become x squared divided by what? 4 plus 5. Are you seeing it? So I can rewrite this again as y is equal to, I can write this again as y is equal to 1 over 4 x squared plus 5. And this is it. So what does this mean now? It means that when we have y, write it in the color. So we have y is equal to x squared plus 5, and you stretch it by a factor of 2, and you stretch in the x direction. Okay, in the x direction, the final equation you're going to get is going to be 1 over 4 x squared plus what? 5. Okay, so that means this graph, when you stretch it, is going to look like this. All right, let's go and check it out and see if we have the same thing. Okay, so this is the green one, right? All right, let's just put the answer for the second one. So we have 1 over 4. 1 over 4 is the same thing as 0.25. Okay, 0.25 x raised to the power 2 and plus 5. Are you seeing it now? So from this now, you can see that in this example here, the purple one was stretched in the what? In the y direction. It moved here. But the black one now, so if you remove the purple one, so now the original one was the green, but now you can see that now it's been stretched in the what? In the x direction. So it moved to give you this one here. Are you seeing it? And that is it. So that means the green one was stretched in the x direction to give you that. Okay? And that is that for that. So that means in this example we just solved, when you stretch it in the x direction, it's going to be 1 over 4 x squared plus 5. And when you stretch it in the y direction, it's going to be 2x squared plus what? 10. Okay. Now, but something you need to look at here. Now, if we go back to the graph, the Desmos graph, for instance, let's pick this first two. Let's say something here. Now, you will notice as well that if you look at this point here, okay, this point has an x and a y, right? And now, after you stretch it in the x direction, the point comes here, and you can see it's going to have a new x, and it's going to have a new what? Y. Is this making sense? So now the question now will be, how can I determine the new value of this x and y from the old one that is given? Okay, so how do you determine this new value? So that means what I'm saying is that you have a particular x and y coordinates. You stretch it by a factor of, let's say, k or 1 over k, depending, either in the x or in the y. What is going to be, if it's in the x direction or the y direction, what is going to be the new what? Coordinates for this. So how are we going to do this? All right, so I have 4 rules of doing this. So I'm going to write it here, 4 rules for finding, okay, for finding new coordinates, after stretching a graph, so it could be either in the X or Y direction, okay? So how do you find a new coordinate after stretching a graph, either in the what? In the X or in the Y what? Direction. Okay, how do you do this? All right, get this out of the way so it'll be easy for me to write. All right, so the first thing you have to do when you are doing this is that you have to identify, okay? You have to identify the original what? Equation. Oh, sorry, I meant the original coordinates. I've been saying equation for a long time now. So what you do, you have to identify the original coordinates from the original equation or from the original equation. Is that okay? So you have to find what is the original coordinates from the original equation. So you can kind of call it X and Y. So the original coordinates. Then when you found that, then the next thing is that you have to then identify, okay? You have to identify the stretch factor, okay? You have to identify the stretch factor, okay? The stretch factor could be K, or you could have a stretch factor of 1 over K. Doesn't really matter. The same method applies regardless, okay? So the first one, now if you're stretching, okay, if you're stretching in the Y direction, let's start with the Y direction to make it easy. So if you're stretching in the Y direction, what happens is that the X coordinates, okay, the X coordinates will remain what? The same. Okay, when you're stretching in the Y direction, the X coordinates will remain the same, but the only difference here, the Y coordinates, to get the Y coordinates, okay, the Y coordinates is multiplied, will be multiplied okay, multiplied by the stretch factor, okay? So what I'm trying to say is that if you're stretching in the Y direction, okay, the X coordinates will remain the same, but the Y coordinate will multiply. So if you have, for instance, we have X comma Y, and the stretch factor is K, and you stretch in Y direction, okay? What we are saying, the X will still remain the same, but the Y is gonna be Y times K, is gonna give you KY. Are you seeing it? Now, if you're stretching as well, and this time you're stretching by 1 over K, and you're stretching the same thing, you stretch in the Y direction. It does not really matter, okay? What will happen? The X is gonna remain the same, but the Y is gonna be Y times 1 over K, and that'll be Y over what? K, okay? And that is it. So if it's 1 over K, because you have Y times 1 over K, and that will give you Y over K, all right? So that is it. That will give you the answer for that. That's how I got that. Okay, now the next one, but if, for instance, you're stretching in the X direction, okay, you're stretching in the X direction, the X coordinates, all right, the X coordinates is multiplied by the stretching factor. Okay, the X coordinate is multiplied by the stretch factor. but the y coordinate is going to remain the same. Okay, so the x coordinate is multiplied by the stretch factor, but the y coordinates what will remain the same. So what I'm saying, exactly the same thing we talked about here. So you have x and y, okay? Now it's stretched by a factor of k, and this time you're stretching in the x direction. Okay? You're stretching in the x direction. So what will happen is you multiply the k with the x, so that will give you kx, but the y is going to remain what? The same. Okay? So that means, and also if you have the x, y, and you're stretching by 1 over k, all right? And you stretch in x direction as well. Okay? Then what you do, the y is going to remain the same, but the x you're going to multiply. So x times 1 over k will give you x over k, and that will be the new coordinate. Okay? Then when you've done that, then number 4, you then write down the new coordinates. Okay, in the correct form. Okay, so you just write down the new coordinates. All right. So let's pick an example. All right. Let's pick an example so we can see how to get the new coordinates for this. All right, so I have an example here. So let's pick this. So we say a point B, all right? A point B having a coordinate of 10 and 15, all right, is stretched by a factor of 5. Okay? What is the new coordinate? When it is stretched in the first one, when it's stretched in the y direction, what will be the new coordinate? And number 2, when it's stretched in the x direction, what will be the what? The new coordinate. Okay, so let's start with the first one. So I'm going to start with the first one in the y direction. So let us see what will be the new coordinates in the y direction. All right, so let's start with the first one. And what would that be? So let's start. So the first thing, step 1, identify the original coordinates for the original equation. So from this point, we know the original coordinates. Step 1, the original coordinate is what? 10 and what? 15. So the original coordinate is 10 and what? 15. Step 2. Step 2 said we should identify the what? The stretch factor. So what is the stretch factor here? We're told that k was equal to what? 5. Are you seeing it? Next one, step 3. Step 3, remember we are stretching in the y direction. So step 3 is stretching in the y direction. The x coordinates will remain the same, while the y coordinate is multiplied by the stretch factor. So the x coordinates will remain the same. So we're stretching in the y direction. So we have 10 and 15. We're stretching by a factor of 5, and we stretch in y direction. So when stretching in the y direction, what x coordinates will remain the same, but the y coordinate is multiplied by the stretch factor. So x coordinates is remain the same, while the y coordinate is multiplied by the stretch factor. So it's going to be 15 times what? 5. Okay? And step 4, we then have to then write it. So that will give us 10, and 15 times 5 will give us what? 75. So the new coordinates for this is in the y direction is 10 and what? 75. So if you want to pick another one, let's, for the second one, in the x direction. Okay. In the x direction, the same thing. We're going to go to the first thing. We'll have to write down the original equation, step 1. So step 1, write down the original coordinates. And it's 10 and 15. Step 2, the next thing is that we then have to identify the stretch factor. So the stretch factor, the k is equal to what? What's the stretch factor for this? 5. So the k is 5. Step 3, okay, we're stretching in the x direction, okay? So remember, it said it's stretching in, we're not doing the y. In this case, we're doing the what? We're doing the x. So it's stretching in the x direction. The x coordinate is multiplied by the stretch factor, while the y coordinates remain the same. So we're going to have this. So we have 10 and 15. We're stretching by a factor of 5. And we're stretching this time in the x direction. Okay? So stretching in the x direction, you multiply this 10 multiplied by the stretch factor, while the y remains what? The same. So step 4, you write it to complete form. 10 times 5 will give you 50. And then you have what? 15. All right? And that is how you do it. So I feel like I should just solve more examples. So I'm going to see if I can add more examples so we can solve now. Let's just add more examples because I've talked about the coordinates and I've talked about how do you get the stretching function for each of them. So we can solve more examples to just make sure that we understood what I said. So I have this example here, and let's see if you can try it. Okay, so I'm going to write it on the board. And what I want you to do is that when I'm done writing, I want you to pause the video and try and solve it. Then you come back and check, okay? So number 1, the question said they want you to stretch the following in either the y direction by 4, okay, or x direction by 3. Okay, so we have y is equal to cos x, and we have y is equal to x squared plus 5x. Okay, so what they want you to do is that for y equals to cos x, stretch it in the y direction. Then after you're done with that, come back to it again and stretch it in the x direction. All right, so you do the same thing for question 1 and question 2. And number 2, we have find the new coordinates. Okay, find the new coordinates of the point 3 and what? 7. So find the new coordinates of the point 3 and 7, which is on f of x after the following transformation. We have first, we have a horizontal stretch. by scale factor of 10. And number 2 is that we have a vertical stretch by scale factor of 3. So what I want you to do, so now just pause the video, okay? Pause it. Then try and solve it. Then come back and see if you get the same answer like I did. Is that okay? Okay, so let me go straight and start solving now. So let's start with the first one. So we had y is equal to what? Cos x. Okay, I'm going to start first with the y direction. Okay, so remember I told you that when you are solving in the y direction, so we're told to do this by what factor? Y direction by a factor of 4. Okay, so y direction by 4. So that means in this case, all the y you're going to have, you have to replace it with y over 4, and that'll be equal to cos x. So therefore, to remove this 4, you multiply both sides by what? By 4. So this will now give you y is equal to 4 cos x, okay? And that will be the answer for that. Y will be equal to 4 cos x. Now, if you're doing in the x direction, okay? In the x direction, and the x direction is by factor of 3, okay? So x direction by factors of 3. The y remains the same, but the x, you're going to replace the x with x over 3. And that will be the answer for that. Y is equal to cos x over 3. Number 2, okay? The next one is we have y is equal to x squared plus 5x. So in the y direction, so we said y is equal to x squared plus 5x. I think, let me write the question first, so it's easy. Y is equal to x squared plus 5x, okay? X squared plus 5x. All right, so let's start. In the y direction, okay? In the y direction, what you do, you replace all the y with y over 4 because we're stretching by 4 in the y direction, right? So it's going to give us y over 4 is equal to x squared plus what? 5x. In order to remove this 4, you multiply everything by what? 4. So that will give us y is going to give us 4x squared plus what? 20x. Okay? And that will give us y is equal to 4x squared plus 20. All right, and that will be that for that. And this is the answer for this. Okay, so I'll just squeeze in this one here. So, but if it's in the x direction, or let me just use another page. See if I can use another page for this. So, the next one in the x direction. So we have in the x direction now. Okay, in the x direction, you replace all the x, right? So we had y is equal to what was the question again? X squared plus 5x. We had x squared plus 5x. So in the x direction, you place all the x. So we have this x here, and we have this x here. So you place all the x with x over k, and that's x over 3 because we're meant to stretch it by a factor of what? 3 in the x direction. So it's be x over 3 squared plus 5x over what? 3. Y will be equal to x squared over 3 squared plus 5x over 3. And that will give us what? Y will be equal to x squared over 9 plus 5x over 3. Okay? If you want to, you can write it again as y is equal to 1 over 9 x squared plus 5 over 3x. Okay? And that will be the answer for that. Good. So let's go to the last one. They said find the new coordinates of the point 3,7 when it is undergoing the following transformation. So the first one is a horizontal stretch. Okay. So if you remember, I told you from the beginning, when we say horizontal stretch, it means in the X direction. When we say vertical stretch, it means in the Y direction. Okay. So we can now solve this question now. So we're having this coordinate 3 and 7 going that. So let's start with the first one. So number 2, I'm going to start with the first one. We have a horizontal, okay, horizontal stretch by factor of 10. Okay, so that was what it said, right? Horizontal stretch by factor of 10. So basically, horizontal stretch, so that is we have 3 and 7 undergoing stretch by a factor of 10, which is going to be horizontal stretch. Okay, or you can say, or stretching in the X direction. So anyone you want to use, feel free to use it. Okay, so when you're stretching in the X direction, the Y remains the same, but the X you multiply it by K, right? So we've talked about this, and the new coordinate is going to be 30 and what? 7. Then the next one is a vertical stretch by a factor of 3. So vertical stretch by a factor of 3. So we have vertical stretch by scale factor of 3. Okay, so we have 3 and 7, scale factor of 3. So it's called a vertical stretch. Okay, or if you don't want it, you can say stretch in Y direction. Okay, stretch in Y direction. When you're stretching in Y direction, the X remain the same, but you multiply the stretch factor by Y. Okay, and this is going to give you what? 3 and what? 21. And that will be the answer for that. All right, so with that, that brought us to the end of the stretching. Okay, it's a long video as well. Like I said, I had to start from the scratch, build it all up so that you can have a good grasp when we start solving questions. So when we're talking about stretching is either in the X direction or in the Y direction. The Y direction is also known as the vertical stretch, and the X direction is the horizontal stretch. When you're stretching in the Y direction, you multiply the whole function by K, while this, you multiply it by the 1 over K. Now, in the X direction, you divide X by K and divide X by 1 over K, but because it's 1 over, you flip it, and that'll become KX. Okay? And how do you find this? The stretching of a graph, you write the original equation, the stretching factor. If it's in the Y direction, replace all the Y with Y over K, X remain the same. If it's in the X direction, replace all the X with X over K, Y remains the same. And we did this, and we solved, and we checked with the graph, and we solved. Then how do you now find the new coordinates, okay, for this? If it's in the Y direction, the X coordinates remain the same, while the Y coordinates is multiplied by stretch factor. If it's in the X direction, the X coordinates remain the same, and the Y coordinates is multiplied by the X coordinates is multiplied by the stretch factor, okay? And we solved some examples. Then I also gave you an exercise to try, and we now solve that as well. Okay, good. And this will bring us to the end for this. The next video I'll be talking about now will be reflection of a graph. Please, if you have any question, let me know. Send me an email, or you can see me. You can stop me around, and I will answer your question. And also, if you've not subscribed or you've not liked or shared, I don't know what you're waiting for, please do so. Click the notification bell so when I post new videos, you'll be the first person to know. All right, so see you soon. We'll talk about reflection of a graph.